Okay, so in this video, what we're going to do is review pages 1 through 4. You guys have already seen the notes filled out for a lot of this on pages 1 through 4. And on some of the questions, you saw the words "you try." And in this video, what we're going to do is we're going to take a look at some of the "you try" questions. And we're going to take a look at those answers and see if you guys got the right answers, okay? So if you guys will join me on page 1. A lot of this should already be filled out if you took the notes. And so what we've got here at the beginning is just the idea of using a proportion to figure out whether or not two figures are similar. Now what you're looking at on the board here is definitely two similar right angles, rectangles. And what we're going to do is we're going to actually mathematically prove that they are in fact similar. Now what we mean by similar figures is that similar figures, over here you guys already have the definition, they have the same shape but not the same size. Now what I'm going to do is I'm just going to highlight real quick. I'm going to highlight that we're matching up side 9 with side 18. That's what's going on over here. Side 9 does match up with side 18. A fancy word for that is corresponds. Side AB corresponds to side EF. Now side BC corresponds to side FG. And that's what we're saying right here. Now mathematically, this 9 over 18 we know is a half. And 7 over 14 we know is a half, which means that's proportional. And that means these are in fact going to be the dimensions of a similar figure. Now what I've shown from green to green and blue to blue is that we can compare corresponding sides. What I mean by that, and I'm going to erase this now. You've got a couple different ways you can see the shape. What I just said was 9 side AB corresponds with side EF. So you can match green to green and then blue to blue and simply then come through and determine if that's a true statement. All right? Now over here, what we've got is green side AB, but what we can now do is we can compare that to side AD. We can then say EF in the other shape matches up with EH right there. AB is side length 9, AD is side length 7, EF is 18, and EH is 14. And for this one, I see a scale factor right there. And since this is a true statement, we know it's a proportion, which means these are the sides of a similar set of rectangles. Okay? Moving on here, what we've got is that A, D, and E, when you fill in those sides with the numbers, we can use the numbers to prove that A is a proportion, D is a proportion, and E is a proportion. All right? Now right here for part B, when we fill in all of the numbers for those sides, and then we try to divide, we see that the decimals aren't the same. You could also cross multiply those numbers and see that those answers aren't the same. And therefore, since this is not a proportion, these side lengths are not with similar figures. Okay. Moving on down here now, we saw a warm-up question the other day where you guys were able to tell me that N definitely equals 39. Now I want to remind you guys that we're going from a bigger triangle to a smaller one, which means we are going to be reducing. And since we divide by 3, our scale factor is in fact 1/3. So now what we're asking is 1/3 of what number equals this 13? And that's what you see here. 1/3 of some number N equals 13. And to solve, we're going to multiply both sides by the reciprocal. That cancels out. And 13 times 3 is 39. All right? Now, if I erase this and trace corresponding sides, we've got that this side, if I color that one red, it corresponds over there to side SU. Now, if I color the bottom here, the base green, it corresponds to side TU. And last but not least, if I trace this in purple, it corresponds to this side in purple. And now you can figure out, with this typo in method 2, you can figure out which one of these proportions makes most sense to you. All right, I'm going to start with a common one. A lot of people see that 15 to 5, you're matching up green to green, 15 to 5. You're going from the bigger triangle to the smaller one, and that's what we're comparing there, big to small. Now, if we're trying to find n, n goes with the big shape, so that's why it's there in the numerator. And our 13 is with the small shape, so that's why it's in the denominator. Right there, you can cross multiply and divide, and you'll get a 39. A lot of people see that. Now, not everybody sees from big to small with the 15 and the 5. Some people see the red 36 goes to a 12. So from big to small, 36 went to a 12. And same idea, n going to a 13. All right? Again, when you cross multiply and divide, you're going to get the same answer for both of these. Now the third thing, not everybody sees, but there are a lot of students who will see, if I compare this unknown to this, I can compare its matching to this. And that's the last thing we're saying here. We're saying n goes with the base 15. So n goes with the base 15. And then over here, we're saying then that 13 goes with the base 5. All right? Same idea, you can cross multiply and divide. Now the last thing that you don't see listed here, I do want to point out one other thing. You could compare purple over red and say n over 36. And that goes with purple over red. And same idea, when you cross multiply and divide, you'll still get n equals 39. So you can decide which of those proportions you're most comfortable with. You might see, once again, 15 matches up with 5, and therefore n matches up with the 13. That would be this first method. And again, you can see this, or one of these. It's up to you. As long as you get that n is 39, your way of thinking definitely is okay. All right? So that takes care of page 1. There's a lot of information in page 1. And my video looks kind of messy right now. The notes look pretty messy. There's a lot of coloring going on. But if you're good with that, we can move now to page 2. And what page 2 asks at the top then is which one describes the relationship between corresponding sides of the two triangles. So I'm going to do some color coding now with a highlighter to remind you guys about corresponding. All right? If I color this side yellow, that means this is the yellow side. They are corresponding. If this is green, so is that. That means side PR corresponds to side DF. And last but not least, if I trace QR in blue, it corresponds with side EF. Okay? So now that we've got our colors, PQ, we traced it in yellow. There it is. Now side DE is also yellow. Now PQ is in fact a 4, but DE right here is 10, not 15. So what that does is it allows you to see that B is correct. What B shows is that side PQ, which is yellow, that is a 4. And DE is also a yellow, and it's a 10. And that correctly shows that this yellow side corresponds with that yellow side. Okay? For C, just to kind of point it out, PR is in green right here, but it has a length of 6. So do you guys see that it doesn't show PR has a value of 6? That's why it's out. All right? And same thing here, side DF is a 15, not a 10. So it's not showing corresponding sides. Before I move on, another true corresponding example would be if I took PR and said, okay, so PR is worth 6. And it is the same over here as side DF. And side DF is actually a 15. That shows that PR is 6, and it corresponds to side DF of 15. So that one would also work if it had been a select all that apply. All right? Now, for this one, a lot of the answers were already filled in for you. And I just kind of wanted to explain real quick now what I mean that all of these will work. I'm going to color code the corresponding sides. 4 goes with the 46. And X goes with the 23. Okay? So what we're saying in this first example is that you can take the 4 and say, okay, so the top 4 has a side of X. This top 46 matches with the 4, and this 23 matched with the X. And all you have left to do is to cross multiply and divide. All right? Now, I think that this next one is the same as that. You're just going to say instead that you see green first, the X on the side matches up with the 4. So this green side, and there's the 46, the yellow. Okay, so those are kind of the same idea. Now, I think that what a lot of you did, though, is you saw that 23 here is half of 46. So you instantly knew then right here that 2 is half of 4. And if you saw that in the pictures, this is the proportion. You saw that the 23 in green, 23 was half of that 46. So your answer here is going to be half of the 4. So far there's a lot of different ways you can see these shapes. In green here, what we have is that X matches up with side 23. Those are corresponding. So if X matches up with 23, we know 4 matches up with 46. Once again, that would work to cross multiply and divide. What do you notice that all of these have in common when we cross multiply? 4 times 23. 4 times 23. 4 times 23. 4 times 23. And the last one, 4 times 23. When you multiply 4 times 23, you're going to get the same answer for all of them. It's going to be I want to say 92. And then you're going to take 92 and divide it by the 46. And you're going to get 2. So it doesn't matter to me which way you see the shapes, as long as you can write down that one of these proportions is what you're using to then cross multiply and divide. Now let's say you're a scale factor person and you love the scale factor shortcuts. If you are a scale factor person, okay, we are now going from a smaller rectangle to a bigger one. That means we have an enlargement. All right? Now you could divide 46 by 4 to get the scale factor. You could easily do that. And in fact, let's take the calculator. So the scale factor is 11.5. 11.5. So times 11.5 is how we got that. So some number out there times 11.5 would be 23. To figure that out, we can simply take the 23 and divide it by that scale factor. Boom, x equals 2. Okay? So that is a method for some of you who prefer scale factor. All right, moving on now to page 3, if you guys want to turn your pages. For question number 2 up here, to find Q, it's going to be much easier if you separate the triangles. This triangle is kind of drawn within the larger one. So what we've done here is we've separated them. This is the smaller one that was drawn kind of right here inside that bigger one. Now I'm going to hit Control Z to undo that, just because I don't want it to be too much colors. And at this point, you can easily see the corresponding sides, okay? So DC, right here, that one corresponds in the same order from D up to C, it's E to G, all right? Now for C to F, that's in blue, so C to F, that goes with G to F. And the last one down here, D to F, goes with E to F. All right? Now for the similarity statement here, we've got 2 triangles. And what we're saying then is angle C matches up with angle G. Boom, there it is. Angle F matches up with angle F. Hey! And then for the last part, angle D would match up with angle E, and there they are. So that's what a similarity statement does. It lets you know which angles correspond with each other. I want to point one more thing out. If I took side CF, again, that's over here in blue, it should correspond right there with G and F, and over here we can see that it does. So the similarity statement, what this thing does, it allows you to determine which angles go together and which sides go together. And my fancy math word for go together is corresponds. All right? Now, if we set up a proportion here, again, it doesn't matter which one of these you like. Some of you are going to see the height Q over the base 8, so the height 3 over the base 4. Others of you are going to go from the bigger shape to the smaller one and say, well, Q, that height matches up with 3. The bottom 8 matches up with the bottom 4. Doesn't matter to me. We're going to cross multiply and get Q equals 6. All right? Now, if you want to scroll down and just take a second to check your work, angles R, angles U, angle T, and angle S are the answers to 3A. All right. Sorry about the bell. And in blue, you can see which sides correspond. Now, to verify, we're saying A should go with R. And what do you know? A and R go together. Okay? B and U should be in the same spot. There they are. C and T, they are. And D with S. And there's D matching up with S. Now, pointing out again, it doesn't matter to me which one of these proportions you are more comfortable with, okay? Some of you see that 30 matches up with a 15, and that Y matches up with a 12. That 30 matched up with 15, and Y matched up with 12. Or you can see, and let me erase this now just so it doesn't get too colorful. Some of you see that Y goes with 30, which means that 12 would go with the 15. That's what we have here, that Y went with 30 and 12 went with 15. Doesn't matter to me. Cross multiply and divide, and you're going to get a 24. Got some scale factor, people. Friendly reminder that the scale factor is actually a half, because we went from a bigger shape to a smaller shape. And if you caught that half of 30 is 15, you can easily just know that Y is a 24, because half of 24 is going to be the 12. All right, once you've got that checked and filled out, you can move over to page 4. Now, what I did for page 4 at the top here was I redrew this second triangle so that it was turned the same way. I see that 12 is kind of that longer slanted side, and it matched up over here with the 27, and you can see they're both there in green, which means our unknown x corresponds to the blue 15. So x over 15 equals 12 over 27, or blue over green equals blue over green. And there's the x over 12 equals 15 over 27. Now when you cross multiply and divide here in the calculator, you're going to get a repeating decimal. We've got 15 times 12. And then when you divide that by 27, take a look. Whoop. Sorry. 15 times 12. Divide by, there we go, 27. So all I did was round that to the nearest tenth for my answer. And we can see that x would be about 6.7 units long. All right, now down here for these U tries. For the first one, x equals 2.5. And here's all the work. We've got a scale factor of a half. Half of 12 is 6. So half of 5 would be 2.5. You could also set up a proportion. And you could compare, I'll highlight it here, height to base, so 12 over 5. We can set that equal to height over base, 6 over x. Again, cross multiply and divide, same thing. Now some of you like to go from one shape to the other shape, so what you could do is say 12 went with 6. 12 went with 6. And this goes with this. It does not matter. We're all going to get that x equals 2.5. And for the second one, you'll see that I took this trapezoid and redrew it. If that's the right angle up above the tall or below the tall side, here's the right angle that's going to be below the tall side. And there's angle X here, matching up with angle B. So 15 is the red side. It matches up with M. Actually, I just found a mistake. Let me fix this real quick. I just found a mistake in my work, and I don't want to have to redo the entire video at the very end. That would stink. So let me just move this over, and you guys can actually kind of watch me do this one with y'all. M actually went up here, and 13 is here. All right, and now I'm just going to retrace. Let me make this one green and green, and now we want those. Okay, cool. So to find M, totally your call. Some of you are going to see that 13 matches up with M. So you're going to go red to red. 13 matches up with M. And 24 matches up with 16. Awesome. When you cross multiply, we're going to have 24 times M. And it'll be set equal to 13 times 16. 208. So if we divide now, 24, we're going to get another repeating decimal, so it'll be about 8.7. Okay. Now, if that proportion doesn't click with your brain, what you could do instead is say that 13 goes with 24. You could say the weird slanty side over the height. So the weird slanty side over the height can match up with the weird slanty side over the height. Once again, you're going to cross multiply. We got a 13 and a 16, and then we're going to divide it by 24. All right, so for that one, we get that m equals 8.7. Any questions for me? You can ask when I get back. I'll be back on Friday. And that takes care of pages 1, 2, yeah, that takes care of pages 1, 2, 3, and 4. So at this time, you guys can stop the video and continue on in the packet.